nobody else is going to be looking at this. You don't want anyone else looking at this. And the question you ask yourself with unit tests is my code doing things right? This is unlike, say, functional testing, user acceptance testing, the rest of the test stack, which asks, is my application doing the right things? So it's fairly small and granular, and we want to keep it that way. So I swiped this list from The Magic Tricks of Testing by Sandy Metz, which is actually a Ruby talk. Don't hold that against her, it's an excellent talk. You basically want your unit tests to be thorough. You want them to cover a decent amount of your code. You want them to be fast. That your unit test should not be overly complicated. It shouldn't be calling a lot of heavy resources. It shouldn't have a lot of branches. They should be stable. You should expect to get reasonable inputs and outputs out of the test. And they should be few. You don't want to torture your fellow devs or yourself with writing a very huge, hard to maintain unit test suite. The more complicated it is, the bigger it is, the less inclined you are to maintain it properly. So be parsimonious. Now, this is the very basic minimum necessary for a test case in Python. We import the unit test module. We subclass test case, which is our basic unit of software inside the unit test module. And then we write a test instance. In this case, we're doing something really kind of simple. We're just testing strings is upper function. And, oops, that's going to fail. OK, never mind. So this is the case of a failing test. And then we have to call the main function in order to actually run the test library. There is more to it, but this is basically your test case inside of unit test. So I just showed you what a test case looks like. That's basically a grouping of related scenarios that you're going to run. I'll cover test fixtures in a moment, and a test suite is a grouping of all the test cases that you're going to run within the unit testing framework. Right. So basically, you want to describe independent testing scenarios within each individual test case. You want to keep them related. So here's an example of a couple of related testing scenarios. We're basically just calling uppercase string functions together. So this gives you a nice coherent test case, which also allows you to write maintainable tests because you expect to see a story with all these different testing scenarios. And it's really obvious to anyone who picks up your code exactly what you're doing, and you don't have to go through and try to figure out a lot of different scenarios inside your test case. So frequently we want to instantiate common services, common variables between the scenarios inside a test case, between all those different functions. So you can go through and actually instantiate things in each one of those methods, but really that's very inefficient. It results in a lot of code to maintain, and you may make an error if, say, something changes or you need to add a new variable. So what we do is we have a test fixture which gives you common setup and cleanup code. And unit test orchestrates running running the setup and the cleanup code automatically for every single one of those functions. Of course, you want to make sure that you don't stack those setup and cleanup codes with a lot of functionality, a lot of system calls, or a lot of resource calls, just because it's going to be slow. So here's basically what that looks like. You override the function setup and tear down to instantiate and, if necessary, clean up a common resource. This can be connecting to a database. This can be getting a request object. There's a number of different scenarios, a common object that you have to make API calls on. And then inside each one of your test functions, you use your common resource. So we saw an example of assert equal and assert true. These are basically the most common assertion methods you would use inside unit test. They basically wrap common operators. You can also insert a message that overrides the default error message that's sent should a test fail. It's not shown in the method signature here, but it's supported pretty much across the board. And I've pulled out another one because it wasn't in that table, but I find it really useful myself. And it uses the with call semantics. And if you don't do this, this will not work, as I found out this morning. So you want to check to make sure that a function that's you would expect to raise an exception actually raises that exception under certain circumstances. So say I've got a function that reads a file and I give it a bad file name. I want to make sure that my find not found error actually gets raised and that I can test for that. So I don't know why they didn't put it in the table, but it's an extremely useful function. So just a couple of extras out of the stock unit test library. If you happen to know that a test is broken or it needs work, you can use the skip decorator to actually skip a test and document why you're skipping it and not use the lame string that I used there. And if you know that a unit test is actually broken and you want to have that recorded in your unit test, in your test suite run, you can use the expect failure decorator and make sure that that actually gets recorded every time you run your test suite. Yes?
So I'm wondering, with the expect failure, does that actually enforce that it fails? Like, does it flip the results and if it doesn't fail, say, oh,
yes, that's exactly what it does. So if it passes, that means there's something very, very wrong with your code. Yeah, so see, I picked an assert equal that I know would fail, and that will be okay. Oh, also, there's a skip if decorator, which I don't show, but you can use it to check versioning in your own library. So say you're running your unit test suite on a legacy version of your library or module, you can actually skip tests that are too old. That's a good way to kind of keep your test suite under control as well. Okay, so that brings me to mocking. So what is actually a mock? It's a testing mechanism that allows you to take a known object, a known service, and double it. This may kind of sound like a testing stub, which would be like an empty class that you populate with a little bit of extra functionality so that if you call something on it, it'll return an expected value. But it goes a few steps further than that. And if you've never read anything by Martin Fowler, I strongly recommend that you start with his Mocks Aren't Stubs article. He is mostly a Java guy with some small talk, and this is a really old article, but it's still worth reading because it's just good software engineering design. And I've collected all these links at the end of the talk as well. But he's basically got an entire write-up on why mocks aren't stubs. I am just going to highlight that mocks have two things that a good mocking library will give you. It will give you behavior verification so that when you call a mocked object or a mocked function, you get reasonable output you get an expected output for the input that you give it that matches the object that you're doubling. And then mocks also set up behavior expectations, which I'll show a bit later too. But this is the important difference between mocks and stubs and why you want to use mocks. It saves you a lot of time and a lot of orchestration code. You want to keep your testing mechanisms as simple as possible because tests are hard to maintain and they're expensive. So you don't want to be spending a lot of time having to write glue code or orchestration code when you have reasonable libraries that you can call on. So some specific examples of why you would want to mock. You want to avoid integration testing. If you write software of any kind of complexity, you're going to end up having objects from another module or another class as inputs to the object, to the module, or the functions that you're testing in your unit tests. If you have to create concrete instantiations of those objects, you've gone from unit testing to integration testing. And that's heavyweight. It is not the intent of a unit test, and you may run into unintended side effects. So in order to keep things simple and modular, use a mock. This helps you also avoid system calls, since we want to keep our unit tests fast. We don't want to have to start calling into the file system, removing files, getting resources. We also want to avoid instantiating and using expensive resources. These can be HTTP requests or querying a REST endpoint. It doesn't make a lot of sense to do that. And also you could run into unexpected failures that have nothing to do with your unit tests. And again, avoiding network requests. Okay, so the stock unit test module in Python has a basic mock class. This is the base class. It's the very simplest mocking implementation. There is actually not a lot to it. You have to manually set up your doubled object attributes and methods when you use the base mock class. Now, this sometimes is desirable if you want to heavily customize the mock object. Say you're a power user and you have a good idea of what you want. You don't want to use any of the defaults that will be in mock subclasses. But generally, I think just avoiding this is fine. So there's a subclass of mock called magic mock, which provides default implementations of mock's magic methods. So you don't actually have to do a lot of orchestration. It's generally more capable than mock, and a lot of the tools end up using magic mock instead. So here's a very basic use of the magic mock class. Say I have a production car class. I instantiate it, but using some Python magic, I can take, say, car's getMake method, which would return the car's make, and give it a magic mock method, which will always return a Honda, so that we're fixing the return value of that function. So that whenever we call it, we will always get back Honda. We call it, you can check the return value if you like, and then the expectation that we've set up is that the function has actually been called. So that is where the assert called function comes in. This makes a lot more sense when you've got mocked functions inside other classes. You want to make sure that it's actually been called. And there's a whole list of these assertion called methods. I'll show one a bit later too, where you can assert that you've called a mock with certain arguments. You can also check for return values. You can check for multiple calls. You can check to see if it hasn't been called at all. There's a lot of flexibility there. So the question is, how, beyond just setting a function, how do we actually set up a mock object? There's this notion of a spec, which is a list of attributes from an object. If you've ever called the dir function on a concrete object, you'll get a list of attributes and methods that belong to that object. That's basically what the spec list looks like. You can basically set that entire list, or you can actually omit functions if there's certain functions in your object that you don't want mocked. You can also generate your spec automatically for your doubled object. And I personally think this is recommended because this way you don't get API drift. Every time you change the API for an object that you're mocking, you will get an up-to-date spec whenever you instantiate a unit test. So here's an example of how to fill in an autospec. You're basically giving autospec the name of a function, and you're setting an expected return value. And autospec will fill in all the expected attributes for that function or object. And we can assert that it's been called exactly once. So here is another example where I've defined another function that takes two inputs and returns none, because I'm just passing. In this case, I'm asserting that I've called the mock function with the same argument list. If I change that argument list, that assertion will fail. This is also very useful for when you're calling functions inside other classes. So an even simpler way to get a mock object to work with your unit test function is to use the patch decorator. It's just basically a convenience decorator that allows you to specify a function on a known class in some module. And if you have to set autospec to true in order to get the full mock object spec to be filled out. There's a lot more parameters that go into patch, like so many that I didn't really want to get into them tonight, but you're welcome to go look them up. Some of them are very obscure and generally don't get touched. But if you're the Power Python user, you might want to tinker with it. And also, just a note, patch actually wraps magic mock, not the mock base class, unless you use a couple of very specific parameters to override that. And then you can do more heavy customizations of the decorator. So once I decorate my test method, I also have to give it an argument that allows you to actually call the mock function that you've cited in your decorator. The naming of this can be completely arbitrary. It has nothing to do with the method signature in the decorator signature. So I just gave it an arbitrary name called mock function. So then, now that I have mock function available, I actually just call the function in the decorator as I would call the concrete class that I'm doubling. And when I call mock function assert called, that will return true because it's actually the mocked function that ran and not the function in the actual car class. Oh, and you can set return value in the patch decorator as well. That's sometimes useful. So you can also use patch to mock an entire class. So if you want to feed a mocked class into another class as an argument, I mentioned that at the beginning of the talk, to avoid basically integration testing. You mock out a class that's used as input to another class. You get your expected inputs and outputs, but you're not actually instantiating anything. You can check to make sure that the mocked class is actually the concrete class that you want, and you can assert that it's actually been called. So there's one other very powerful mechanism in the mock library, and that's side effects. Say you're calling a function that you expect to throw an exception, and you want to make sure that that exception actually gets handled properly in the test function code. You can set up a side effect to actually throw the expected exception when the mock is actually run. And that way you check to make sure that it will be handled. If it isn't, you've got a problem. So side effect can also be used with arbitrary functions, not just exception objects, but exception is a very common use case, so I thought I'd highlight it here. So in order to successfully use mocks, you want to keep in sync with the API of the object that you're doubling. So again, use the autospec mechanisms. if you're using the patch decorator or if you're instantiating a mock object. Keep your mocks simple. It's very easy to run into a lot of problems if you make your mocking code overly complicated. You just want to make sure that you're testing interfaces. Expected input in, expected output out. That's it. And like I said, generate your specs automatically and you should be good. So Python, being amazing and really functional, can go beyond just constructing out basic mocking objects, because a lot of the stuff I've presented you can get in things like Google Test for C++ or other language frameworks. But with Python tools, you can go pretty far beyond that. Also, say you want to mock an HTTP request, there's still a fair amount of orchestration code you have to provide in order to get that to work. So someone has written an HTTP-mock library, which is actually really useful to mock those HTTP requests. And another one that I found recently is called Local Stack. This is provided by Atlassian, and it actually mocks out a fairly complete list of Amazon Web Services like Lambda. So you can test that on your local machine, which is really cool. I've played with it a little bit. You just basically start it up. Your endpoints are running locally on your machine, and it's all mocked out. You just feed it data or say your Lambda command, and you actually get something reasonable back out at the end. It's really pretty amazing what Python can do. So finally, this is a collection of the sites and the articles I've cited. They're not all Python except for the last one. This gentle introduction is a fairly good article. But really, the Sandy Metz talk is excellent. Kent Beck's article, that's a very old article, but it's kind of a classic write-up on testing. It's small talk, which is antiquated. I'm willing to bet almost nobody here has seen it, including me, but still a good read. And I recommend reading Martin Fowler regularly because he is a great software engineer, and you can learn a lot. And that's it.
That's what you got?
That's what I got.
Thank you very much, Anna. Any questions for Anna?
Yes.
Does Mox provide any sort of statistics when you're done using it, like how covering?
Nope. Nope. That would be more part of the unit test framework itself. Okay. But Python being as powerful and flexible as it is, I wouldn't be surprised if you could probably write something up that, like number of times a mock has been called, maybe even how many lines of code it mocked. I don't know. Probably how many times it's been called at least. Anyone else? Yes?
Is there the size of your project, which kind of makes it profitable to implement unit testing?
I would say from the very beginning.
Okay.
I'm a big proponent of test-driven development because I've seen what can happen when you start even a small project without considering testing. You can develop code that isn't very modular and doesn't expose decent information to other clients of your code. So I would start at the very beginning, or even just before you even start planning out your classes. Try to just, sketch out how you would test some basic functionality, some of your core classes, and then go from there.
Maybe it is out of scope of this topic, but is there any way to get the code coverage?
Again, that would be a function of the entire testing framework, or you could use external tools. I don't think JUnit does it. You would have to use an extra tool for that. I don't think Google Test does it either.
I can answer that with that. If you use PyTest, you will run your unit tests, and if you pass a few options, it will send the test coverage and code on the screen.
Okay, yep.
Yeah, and also the code coverage module can do code coverage on anything. So if you run it through code coverage and then so you run code coverage and then your test, it will still work.
Okay.
Regardless of
You must have some decorators or something that do that. like-
Well, you run it through the command line, so you pass it, you say coverage, and then you say what you would have typed after it, and so it will wrap the whole thing basically. It's kind of cool.
Okay, that's neat. That's good to know.
After doing tests in Python, would you ever want to test in C++ again?
I don't have a choice. But I gotta say, the Python testing is so much more user-friendly. It's so much more flexible. Orchestrating Google test mocks is better than a lot of other options, but it's still a little painful.
So in the test cases, like, is there any possibility of grouping? What I'm trying to say is that, let's say if I want to define this test case related to this functionality, if I don't want to execute them in certain time, instead of just like say skip as a general convention, as part of the decorator, can I define this test case as part of this functionality? Like for example, a specific module or whatever it is.
I think you could do that with the test suite module inside unit test. You could group related test cases together, have them run under different circumstances.
So that is at the suite level, but at the class level, when I'm declaring the test case, can I group? Can I do custom tags or something?
I suppose you could write your own decorator.
I test will do that, standard.
Yeah, maybe there is a decorator. I didn't dig too deeply into the available decorators for the stock unit test library, but there's also other Python unit test libraries available that probably go beyond what the stock module does. So maybe worth digging into that. Or there's always, just implementing your own decorator. Okay.
Another round of applause for awesome talk. Awesome. I should have my agenda up so I just don't start talking about stuff. And I forgot. Mind if I steal that?
Please. Can I stop your screen share?
Oh, yeah. So, what number did we get to?
27, I believe.
Who's 27? Look at your tag. Who's 28? No? Good. 29? Sometimes you skip one. Off by one errors. We're coders. It happens. Cool. So we have 28 Pythonistas because I'm number 0. There's your off by one error. And boom. This is basically how I've been doing the raffles now. And int number of Pythonistas. Now, stump question for you. How would I write a test for randomness?
Well, you can actually mock out the random functions.
Good answer. Just mock it.
Mock it. In fact, I found a bunch of use cases online for
mocking
blog
random.
posts on how to mock wrapping the random library.
Nice.
It's a very common use
Sweet.
case, apparently.
Well, that's a good answer. Go ahead and press enter, and you get to draw the first person.
Cool.
Only you'd written that test sooner.
Just by your brain, right? Like 1 to another.
Yeah, one
second,
inclusive range.
0,
You're right.
Yeah.
I 0.
Boom.
We're on 3.6. Use secrets.
Yeah, there you go.
That's what I get for not writing tests. Let this be a lesson to all of you.
Eat broccoli. Go to bed early.
Nice. 19.
That's me.
Awesome. Your choice.
Was this one?
No.
I'll
Actually,
take
that
this
was the
one.
Fluent Python.
That's a good book. I just got it recently.
I think I stole this from a library at one point.
We all have. Go ahead. 12. Who's number 12? All participants must be present to win. Going once. How do you not have 12? No?
They left.
Did I skip a 12?
Did anybody? Yeah, somebody probably skipped it. I don't think
Lucky
anybody's
number
left.
12.
Lucky number 12. Sweet. Well, press enter again. 8. Lucky number 8. Boom. And you're new, right? Oh, I love it when a newcomer wins. And as usual, I'll always tell my story of when I went to the Salt Lake City Linux user group, aka Slug. It's always the best.
Is that defunct?
It's
I don't.
different.
Is it? Oh.
Okay.
Don't make me start another user group. Well, there's.
No, you want to.
I really, really want to, but I won't. I have too many things to do.
The slug and the snake, we could have like.
I know. That's even like a good name for a fundraising dinner. The Slug and the Snake fundraising dinner. Anyway, I'm overthinking this. Anyway, that was the group I used to go to on the regular at the U, and I got my first solid programming book there, and it was a Ruby book, and it was like Rails and using Rails to make your own social media website. And how I got it was somebody else wanted it, and I was like, hey, that's cool, can I take a look at it? And they're like, just keep it, kid. And it felt like, it was like the Michael Jordan moment, where they just throw the jersey. But and then I started coding in that, and then Django came out very shortly after, a couple months after, and the rest is kind of history. So that's my hint for people who got a book and aren't sure what to do with it. So that concludes what I got for tonight. You don't have to go home. In fact, if you want to talk to me about giving a talk, I'm always keen on that. If you want to talk to me about emceeing, we definitely need that. I need to talk to Matt and the Triforce, and other than that, I will see you guys in August. But there will still be a meetup July 12th, right here. So thank you very much. You guys have a good evening. Drive safe when you get home. Perfect.